Hey y'all, my name's Sam and I'm a chemistry tutor here on Wyzant. Our question is help please. Okay, very urgent. How many moles of nitrogen gas are needed to produce 620.69 grams of NH3, assuming an excess of hydrogen? And actually sort of give us our balanced reaction here as well. So this is actually a pretty classic stoichiometry limiting reagent sort of problem. And I love this analogy that I'm about to show you right now. So the first question is, if I'm in a car factory and I have 7 wheels and 2 car bodies, how many cars am I allowed to produce? Some students might think, okay, you have 2 car bodies, that means you can build 2 cars. But unfortunately, we're actually limited because all cars, at least to my knowledge, each require 4 wheels. So instead, in this case, we're limited by the number of wheels. So we would say wheels were our limiting ingredient or component. And the secondary analogy would be, what if we have an excess of wheels, like 1,000,000, 1,000,000,000,000 wheels, and we have 2 car bodies? Then in this case, we're going to be able to produce 2 cars because the quantity that was given to us would be considered our limiting. So I'll say bodies were limiting. I like to come back to this analogy because cars are much more fun than some of these chemical compounds we deal with, but I hope it makes sense. All right, next what I would do is probably rewrite the chemical formula. I didn't include states of matter, but it isn't quite relevant for this problem. Let me just double check that it's balanced. We've got 2 N's, 2 N's. 3 times 2 H's is 6 H's. 2 times 3 is 6 H's. Great. Then I know that the molar mass of NH3 is 17.031 grams of NH3 for every mole of NH3. I get this information by summing the masses from the periodic table for 1 nitrogen and 3 hydrogens, or you can always Google it and make sure that your answer is the same. Okay, so now we're going to get into the stoichiometry because I think we have most of the information we need. We'll start with our beginning quantity, and I highly, highly, highly recommend that you include things like units and the species that you're working with because it'll be really important soon. So we've got the 620.69 grams of NH3. And first, we want to take this 2 moles of NH3. Our balanced reaction includes information about the molar ratios between these substances. So for example, if I put in 1 mole of N2, I also need to put in 3 moles of H2 to get out 2 moles, etc. It's not in terms of grams. So sticking with grams is not going to be very helpful. I want to get out of grams. So I use a version of our molar mass. Although you'll notice it's kind of like the inverted fraction of our molar mass. And that was very strategic. It's because we don't want dependence on grams anymore. So if I do it this way, we get to cancel out the grams. Pretty convenient. Now we need to cancel something else, which is the dependence on NH3. I don't quite care about NH3 because it's the initial quantity, and we're worrying about how much nitrogen was needed. So I'm going to go from NH3 to N2 using the relationship of the coefficients given by our balanced chemical reaction. So I multiply our initial quantity by this to get some number of moles of NH3, then by this to get moles of N2, and I believe that should be our answer. So when I put it in my calculator, I get a long decimal like this. But the last step is to reduce the number of significant figures. I would choose 5 significant figures because we have 5 as our initial quantity, and that's basically how accurate our measurement was in the laboratory or wherever they got this number. And then it looks like we're doing multiplication and division, which means that our sig fig rules are telling us to preserve the total number of significant figures, which in this case would be 5. So I would get 18.222 moles of N2. I hope that was helpful. Thank you.